In this video, we will continue to learn about using quadratic equations and the quadratic formula to solve some real-world problems, applications. Almost all of these quadratic word problems involve this type of situation where something is being thrown or shot in the air and it goes up and it comes down. So each problem just depends on which one of these three positions we're being asked to find. So if they ask us to, if we're finding this point, and you'll know because they'll say something like, what's the highest point reached by the ball, or how long does it take for the ball to reach its highest point, then you're looking for the vertex. And we can find that by the x-coordinate of the vertex will be opposite of b over 2a. And then we can find the y-coordinate using the calculator. Okay? If they're asking us to find point C, that's when they'll say something about the ground, all right? How long will it take for the object to hit the ground, or something like that. If they ask us that, then that just means that the height is 0. So we'll just plug in 0 for the height and solve using the quadratic formula. Alright, these are the two main things that we get asked. Occasionally they'll ask us, well, how long will it take for the objects to reach a certain height? So maybe they'll say, well, how long will it take for the object to reach, let's say, 100 feet? Okay, a height of 100 feet. And in a case like that, it's going to hit 100 feet, or whatever it is, twice. Once on the way up and once on the way down. But again, just like when we were talking about the ground, where the height is 0, they're just giving us the height. So we'll plug in this number for the height and solve using the quadratic formula. So I basically just described all of the problems that they ask us. So we just got to figure out whether we're finding the vertex, are we plugging in 0 for the height, or are we plugging in some other number for the height. So now watch these problems happen over and over again. So for problem number 1, okay, we have a football being thrown, and here's the equation for it. Okay, let's see, take note of the units. Yards. Okay, the height and distance is in yards. And let's see. Alright, from the model, what is the highest height that the quarterback can throw? Okay, so which one of these three things are they asking us to find? A, B, C, or maybe one of these points? Because I need letters for those too. They're asking us to find B, the vertex, because they're saying what's the highest. Okay, so fine, let's find the vertex. Alright, before we do anything else, it's important to understand what x and y are. In many other problems that we've done before, x was time. So this would represent the path of the ball over time. But that's not what it is this time. The problem says that x is the football's horizontal position. So in other words, literally, the y value is the height of the ball, but the x value is how far the ball is, how far it is across the field or whatever. Okay, it's the horizontal motion. It's not time this time. Okay, so let's just jot that down so we don't forget. So now x, when we find x and y, it really is the traditional meaning of x and y. X is the horizontal distance It's an E. And y is the vertical distance, also known as the height. Okay? So just keep that in the back of your mind. So now let's go ahead and find that vertex. The way we find the vertex is we'll find the x-coordinate of the vertex by doing opposite of b over 2a. Alright, so opposite of b, so that'll be negative 0.45 over 2a. So that's 2 times negative 0.025. Alright, so you could type that in just like this. So we get 9. Okay, so this is going to be 9. Alright, so as far as the vertex, that means so far we know that the vertex is 9 comma something. Alright, now we just need to know the y value that goes with 9. If we want that, we can just put the equation into our calculator and find the y value that goes with 9. So type this into your TI-30 XS multi-view. Alright, here I'm putting this in the calculator. Plus 2. Okay, it's asking me where I want to start. But I know that I want to know the y value that goes with 9, so let's start at 9. Alright, and just hit enter like 4 times. So, at a horizontal distance of 9, the height is 4.025 feet. Alright, maybe I need to write this bigger. Okay, so horizontal distance of 9 feet. The height is 4. I already forgot what it was. 025 feet. Okay, alright, so from the model, what is the highest height that the quarterback can throw? So which one of these numbers represents the highest height that the quarterback can throw? It's the second number. Remember, the second number, it's the y value that is the height. Okay, so that's why the answer to part A is 4.025 feet. Now, a receiver is 25 yards away from the quarterback. Can the quarterback complete a pass to this receiver? Explain. Okay, 25 yards away. So, for example, at the highest point, the ball is 9. Wait, I said feet, but it's in yards. My bad. Let me just change that real quick. Alright, so this is in yards. Okay, so that means not feet, yards. Alright, so for example, at its highest height, the ball was 9 yards away from the quarterback where he threw it. Okay, so just as an estimation, alright, this won't necessarily be exactly true, but if this is 9 yards away right here, okay, the highest point is 9 yards, then this point, the farthest distance when the ball comes down and hits the ground is going to be something close to 18 yards. Alright, not exactly, because we're not starting from 0, right? This represents this rectangle represents like the height of the quarterback, or I guess if I was more specific, the height of the quarterback's hand when he throws the ball. You can tell what a great artist I am. So yeah, you got your football. Okay, but he's not throwing it from the ground, so that's going to throw off the symmetry of the graph a little bit. But just as an estimate, it should be something close to 18 yards. It won't be exactly 18 yards. So 25 yards seems like it's going to be too far for the quarterback to reach. Something closer to 18 yards is going to be the maximum. But let's go ahead and calculate exactly how far he can throw the ball. The maximum distance he can throw will be at this point C. But at point C, alright, this is as far as he can throw. The thing we know is that the height is 0. Okay, so let's plug in 0 for height and find out what this point C is. Okay, so what we're doing right now is we're finding point C. And the one thing we know about point C is the height is 0, and we're going to find the x value that goes with it. So what that means is, looking back at the original equation, and here it is. So if we want to find point C here on the ground, that means let's plug in 0 for the height. So this equation will become 0 equals negative 0.025 x squared plus 0.45 x plus 2. Okay, so we are looking for this x value, so we just need to solve this equation. Alright, and we are going to use the quadratic formula. But first, we will find the discriminant. So this discriminant is b squared minus 4ac. So that's going to be, alright, so b is this 0.45. So b squared minus 4a and then c is 2. Alright, so this is the discriminant. Let's figure out what that is. So here I'm typing it in. B squared minus 4a, and then c was 2. Okay, so this is the discriminant, 0.4025. Alright, so now we can go ahead and do the rest of the quadratic formula. So that's going to be, so x will equal opposite of b, so that'll be negative 0.45 plus or minus square root, and then under the square root, that's the discriminant, b squared minus 4ac, that's this, so I'll just put that in, all over 2a. Okay, so this is a. So you know what, I'm just going to write 2 times negative. Okay, there's 2a. I'm just writing it down. Okay, so this is what we have. So we just need to evaluate this. Now, since we're looking for a decimal anyway, we can pretty much type this whole thing into the calculator. Only we can't type in plus and minus at the same time. So let's type it in once with a plus and see what we get, and once with a minus and see what we get. Alright, start off by hitting the fraction button. Okay, so we have negative 0.45, so negative 0.45 plus square root of 0.4025 okay, over 2 times negative 0.025. Okay, so there we've typed it in. So I'm getting negative 3.69 yards. Okay, now right away I know that one doesn't make any sense. Okay, the negative 3.69 yards is like behind the quarterback. Okay, it's behind where they threw the ball. So that's not the one we want. Okay, you can't have a negative distance. Okay, so let's just disregard that answer. That's extraneous. It doesn't make sense. So hopefully the other one will be more reasonable. Now, as a shortcut, if I don't feel like typing in all these numbers again, if I hit the up arrow key and highlight this expression and hit enter, it brings the expression back, because all I really need to do is change that plus sign to a minus sign. So I'm just going to arrow my way over, make it a minus, and hit enter. Okay, so I'm getting 21.69 yards. Okay, and that makes more sense. Okay, so this is the x value of point C. Okay, so that means 21.69 yards. That's how far away this can go. Alright, that's the furthest distance that the quarterback can throw before the ball hits the ground. So can the quarterback reach a receiver? So if this is 21.69 yards and he has a receiver that is out here at 25 yards, okay, so we've got a receiver out here at 25 yards, no, he's not going to be able to reach that guy. Okay, that guy is too far away. Alright, so we can say no. The ball hits the ground at a horizontal distance of 21.7 yards. It will not reach a distance of 25 feet. Alright, something like that would be a good explanation of why no, he can't reach that far. What is the longest distance the quarterback can throw? Well, we already answered that. The longest distance is 21.7 yards. Right? We had to answer question C automatically in order to answer question B. So 21.7 yards. Okay. So that's it for problem number 1. Alright, I sort of took a long time explaining problem number 1, so I'm going to have to end this video here. Hopefully I can explain the other problems a little. Maybe I need to talk a little faster. This is taking a long time. 20 minutes for one problem. I talk too much.